you should have been looking at this left right triangle, and you could have said something like tangent of 19 is opposite over adjacent. The problem is that the adjacent for that right triangle is not 30. It's something less than 30. And then over here you start to set up a SOHCAHTOA equation.
I think it's 14, not 19.
Oh, 14, thank you. My handwriting's too sloppy. And you say, okay, well, from this right triangle, I could do tangent is opposite over adjacent, but you don't know how big this length is, except that it's less than 30. So at some point, what you got to do is you got to say, okay, I don't know this length, so I'll call it x maybe. And I don't know this length, but it's 30 minus whatever x was. So we have to introduce the second variable. There's something else that we don't know. Now, what kind of makes this question a pain is now to solve this, we've got two equations and two variables. So that's a system of equations. So the same system of equations that you learned in Algebra 1, where you talked about elimination method, substitution method, graphing method, should have come up again in Algebra 2. Should have done those, and then you even learned how to do it with matrices. But just to be frank with you, in higher mathematics, substitution is 99% of what you're going to do. So what I mean by that is we have to take one of these equations, whichever one you want, and solve it for a variable. So I would maybe solve this bottom one for D, substitute it into the other equation. So instead of saying D, I can say x tangent of 34. And now my equation's not pretty, and it's going to take several algebra steps, but this is much better because it only has one variable there. It's only got x's in it. I can't solve for two variables, but I can make an equation that solves for one variable. So we could multiply both sides by that denominator, so you no longer have fractions. If we're trying to solve for x, we got to get all the x stuff on one side somehow. So tangent of 14 is just a number. Let's distribute it. I've got some x's on the left and some x's on the right, so we need to make a decision and move them all to one side. I'm going to add this over. Now, these are like terms, but they're not something I can do in my head. If this was 5x plus 3x, I could quickly say that's 8x. But since this is some weird decimal of x's plus some other weird decimal of x's, I can't do that in my head. So the next best thing is a GCF. Say they both have an x, so let's factor that out. And the reason that trick works out great is because now x times this stuff can be undone with division. And now I know how big x is with the help of my calculator. X is 7.062. That would be kilometers. And then if you're not careful, you're going to circle that. You're going to say, well, I did all that work. Surely that's the answer. And no, that's not what it was asking for. It was asking for D. But that's just going to add one step here. I can substitute one more time. D is that times the tangent of 34. Okay, I must have hit a wrong button in here somewhere.
I think you put 35 instead of 34.
Yeah, I think you're right. Okay, that's what it was. So then you plug it in here, and then finally you end up with an answer of D, which was 5 point. Yes. If it's on the practice worksheet, I don't know why it wouldn't be on the quiz. So the best thing about this question, though, well, one, when we learn law of sines and law of cosines, we can actually take a little bit of shortcut when we want to know this. But this type of work, those of you that plan on going to calculus next year, this is very, very, very common to have questions where, you know, the trig in here, the trig is not difficult. The trig was setting up these two SOHCAHTOA equations. But then algebra of multiplying both sides by this so there wasn't a fraction, thinking to distribute, thinking to isolate your variable, thinking to factor out a GCF, thinking to undo times with divide, having the wherewithal to know that this wasn't the final answer and it needed to be plugged in. Longer questions like that have lots and lots and lots of algebra to them, lots and lots of places where if you miswrite 34 is 39, like I did, your answer's off. That's very, very, very common in calculus. You have to be willing to persist, and sometimes it's frustrating because the questions take a long time, but it's very similar in that the calculus is usually just a step or two and not very difficult, but then the 10 steps of algebra that go with it are not so easy. But